Hey everybody, welcome to another fundamentals video. Based on the positive feedback from the last video, I'll try to keep the balance between technical depth and simplicity so that everyone can really understand and follow along. To start, I want to take a journey to a place that's weird, surreal, and somewhat strange.
The latent space.
The latent space is one of those terms that gets thrown around in machine learning and sounds very complicated and complex, but there's a simple way to understand what the latent space is. The latent space really just refers to taking all kinds of different data, whether it's images, text, sounds, or anything else that can be made digital, and turning it into kind of like a math soup that machines can understand and interact with. You're really just boiling down all of this digital content that we see and interact with as humans in different formats and turning it into numbers so that the machine learning model can look at it, understand it, and determine the patterns that it's able to find between those numbers. And in Invoke, you'll see reference to two different states of an image. The image as it is seen by us, and that is just an image, a PNG file that you would normally find on a computer, and then the latent version of that image, which is what a machine learning model can interact with, and the format that can be used for most of the operations that involve machine learning in workflows. The most important takeaway here is just that in order for a machine to interact with the information that we're giving it, we need to turn it into a format that it can understand. And similarly, once it's done processing that information, we actually have to turn it back into the format that we as humans can perceive. And that's what we'll talk about next. So let's denoise the denoising process and break down what exactly is happening in the diffusion process for generating an image. In the previous fundamentals video, we talked about how a model and noise can be used to generate the image. Well, that denoising process happens in the latent space. And we talked about how a text prompt can be passed into the model with that noise in order to generate an image. However, the text prompt and the image are in formats that we can perceive. So that means they're inherently not in the latent space. And a lot of what we're about to talk through in this workflow video is about how information can be transferred into the denoising process and out of the denoising process into formats that we understand. There are three specific elements used in this process. And you may have heard or seen references of these and kind of just taken them as acronyms or not really known what they mean, but they are the clip text encoder, the UNet, which are the model weights, and then the VAE, which decodes the image. The basic process here to understand is that the clip model helps take our text and turn it into a latent representation or format of that the model can understand. And the VAE takes the latent representation of the image after the denoising process and gives us our final image. But let's break each of those steps down even further. When we pass in a prompt, the text encoder is actually tokenizing all of the words that we pass in, which basically just means it's breaking it down into the smallest possible parts it can, mostly for efficiency's sake. And the encoder is then taking that and converting that into the language that the model was trained to understand, which is represented by the conditioning object. In the InvokeAI workflow system, this is encapsulated in the prompt node, which takes in the clip model input, allows the user to define a prompt, and then outputs a conditioning object. The denoising process is also pretty simple. We have the model, the noise, our conditioning object inputs,
the denoising settings, config scale,
step scheduler, latents, control images.
Okay, maybe it's not that simple. But if we take a look at the denoise latents node, which is where most of the denoising process happens, a lot of these things are optional or only used in certain workflows. And for this video, we'll just focus on understanding the basics or the required inputs, which are the positive conditioning, the negative conditioning. And again, both of those are just prompts. Our UNet, which are the model weights. And again, that's just coming from the main model that you've loaded up. And lastly, the noise, which for the sake of technical accuracy is turned into a latent representation of noise when we use the noise node. The steps, CFG scale, and scheduler operate just like you would normally operate those in the regular UI. I won't go into detail on those settings and how they work, as I think there's a lot of documentation around the internet on those specifically. But of course, we may cover that in a future video. I'll briefly touch on the denoising start and denoising end. In the previous video, we talked about the denoising timeline, and this just tells the system where in that process it should start and end. For a new image generation, that will always be a start of 0 and an end of 1. More advanced workflows might have you breaking that apart so you can apply different settings to each part of the generation. Once that denoising process is done, we have on the outputs here our latents object. And again, latents are in a form that we can't see, but that the machine is operating with. And at this point, we can either take that latents object and do something else with it, or if we're really just trying to understand the basic workflow, we just need to turn that back into an image that we can see. And that's a pretty simple process called the decoding step, where we pass the latents through a VAE, which is short for variational autoencoder, and that produces the output image. That step is done on a latents to image node. We tried to name it to keep it pretty simple here. And there are a couple of options on that node, but those are mostly just for performance sake. They don't have too much of an impact on the output image. And so unless you're following some sort of optimization guide to improve performance on your system, you can just ignore those. So the basic workflow is made of just a couple of nodes that are pretty simple to understand once you know this entire process. We have our positive prompt, our negative prompt, our noise, our denoising step, and our decoding step. And all of those are supplied models by a model loader. So let's jump into Invoke and see what that workflow looks like. Now that we're in the InvokeAI workflow editor, we can begin to compose the basic text-to-image workflow. Now, I will call out, if you're wanting to do a basic text-to-image workflow, it's probably better to just use the text-to-image tab. You have all of the options there, and we're composing that graph for you. Ultimately, understanding how to create new workflows inside of the workflow editor allows you to define very specific steps and processes that your image goes through during the generation process to really customize and apply the technology to a variety of use cases. This is especially helpful in professional workflows, where you might find that your team is using specific techniques at different steps of the pipeline in order to create new content and assets for the creative projects that you're working on. So we'll get started with a basic workflow, and then we'll begin experimenting and toying with that to show what flexibility is capable inside of the tool. Just like we covered earlier in the video, I'm going to get started by creating a couple of the basic nodes that we're going to need for our core text-to-image workflow. First, I'll get started by creating 2 prompt nodes by hitting the spacebar and typing prompt, and then selecting the prompt node. I'll select that node, hit Control-C, and then Control-V, and move my second node down. I'll add my main model. I'll add my noise. I'll add my denoise latents node. And again, to finally decode the latents, we'll do latents to image. And now we have our main nodes to create our text-to-image workflow, but we need to connect them up. So to get started, I will kind of arrange my nodes a little bit to my liking, and I'll select the Invoke Fantasy and Art model in order to get started. I'll begin by walking through each of the steps that we talked through in the video and connecting those nodes first. So we'll go ahead and add the clip model to the clip input on the prompt boxes. That allows for the clip text encoding model to be loaded and process those prompts into the conditioning outputs that we're going to need. I'll take the conditioning output from the top and put that into positive, and the conditioning output from the lower node and put that into negative. And just to remind myself of which is which, I'll go ahead and rename the nodes by double clicking on the title and just typing in the new title I want to give it. Now I can also rename the field as well, which can be useful when we add these to the linear workflow, which I'll do now. When you have fields that you want to expose to other users if they're using this workflow again, or if you anticipate using this yourself and needing to change certain elements routinely and often as you reuse this workflow, you can right-click the field name of any field inside of your workflow and add it to the linear view. That'll move that field directly over into the UI on the left-hand side of the screen and allow you to easily update the text inside of your graph. This is a great way of really just simplifying the experience for anyone you're sharing the workflow with across your team or organization or the community at large. We'll go ahead and add the negative field as well, and then continue on with our connections. Now, with our prompt nodes fully wired up and connected both to the clip model as well as passing their conditioning into the denoise latents, we're also going to need to pass the model weights or the UNet into the corresponding field. And we'll go ahead and add our noise in as well. Now, one thing to call out is that the default setting for the noise node is a seed of 0. You'll recall from earlier videos that if we use the same seed and the same settings, we'll always get the same image. If we're trying to make this workflow dynamic and reusable, we probably want to go ahead and add a random element to that seed. And that can be done using the random integer node. The random integer node just outputs a random value between the low and the high inputs, and we can just go ahead and plug that directly into the seed. One thing I find very useful is minimizing these when we are done wiring those up, and you can shift and then drag in order to select multiple nodes and move those to a good spot. Now we'll go ahead and update our steps and our scheduler to our desired settings. For this, I'll go ahead and use Euler Ancestral. And then last, but certainly not least, because this is what gives us our final image, we'll connect the latents node to our latents to image node. Now, one thing that's important to do if you're intending to have images saved here, you're going to want to make sure that the Save to Gallery option is selected for this final node. You may not want to save these intermediate images to the gallery if this is part of a bigger workflow. For example, if we're going to take the image after its output here and remove a background or upscale it in some way, we might want to just wait until the very end of the whole workflow in order to save the image to the gallery. But in this case, we're just creating a simple text to image workflow, and so we'll save this one to the gallery. If we want our workflow to be saved into the image's metadata, we can also click the Embed Workflow option. Very useful if you want to reference back which workflow created your images, or if you're sharing the images out and want that workflow to be distributed as well. One final step that we need to do in order to make sure that this graph can execute is connect our VAE into the latents to image node. With our graph created, we can now update our prompts and generate an image. Now that I've typed in my prompts, we'll go ahead and generate an image. As we generate that image, each of the nodes executed its individual part of the process. You can actually click into any of the nodes that you would like and see their output. And once we're done, we can click our gallery and view that final image. Now let's say that we wanted to change this into an image-to-image graph. How would we update this? It's pretty simple. We just need to add the latent version of our image into the denoising process and update the start and end based on the strength that we'd like to see. So let's go ahead and add in an image primitive node. And in the node workflows, a primitive is really just a raw type. So if you use, for example, a string primitive, that's just a text string. You use an image primitive, that is just going to be an image. And that's where we can upload our image file. So we'll upload that into the image primitive node. And what we'll notice is that we can't actually connect this image to the latents node. That's because this is in the image form and needs to be converted to the latents form first. And so this is a pretty simple process. We've got an image to latents node, and that will take this image, convert that into the latent version using the VAE, and then output our latents. So I'll add this image in. I'll take our VAE and connect that in. And then I will output our latents object into the latents node. Now we're passing in a latent version of this image into the denoise latents function. So I'll go ahead and move this around. And actually what I'll do is go ahead and add the image to the linear view, and we'll use our field updater to call this the initial image. And then close that back up and move that down. With our initial image in the graph, we now need to decide where we want the denoising process to start. Now, in the last fundamentals video, we talked about denoising strength. The higher the strength, the earlier in the process generation starts. In the workflow editor, you directly control when that denoising process starts. So if you would normally do a denoising strength of 0.75, you'll start at 0.25. That just means that we're passing in that latent image, combining it with the noise, and placing that into the denoising process roughly 25% of the steps in. And now we'll update our positive prompt to a broken ice cream cone and see what we get. And if we want to take a sneak peek at what that looks like, we can expand our outputs there. Now, if at any time you want to keep an eye on your current image, you can just add that current image node or progress image node. This will interact with the UI similar to how the viewer does in other tabs. And so if you select an image from your gallery, that'll switch over and you can zoom in if you want to get a bigger view of that. Now that we've created a basic image to image graph, I'm going to delete out our image primitive and image to latents nodes to go back to our text to image graph. And I'm going to reset the denoising start to 0. And then we'll walk through creating a high res graph. We take a model that was trained on a smaller image size, like Stable Diffusion 1.5, which was trained on 512 by 512 images, and we help it create an image at a larger resolution. When you normally do this with these models, you find that there are a lot of repeating patterns, multiple heads, and other abnormalities that you really don't want to see in your imagery. What a high-res workflow does is takes the model, generates that initial composition at a smaller resolution, like 512 by 512, and then upscales that after it's generated in order to run an image-to-image pass on the upscaled image. If you ever used InvokeAI in prior versions, the high-res fix toggle effectively just did this workflow that we're about to build. And with new features like ControlNet, we can make that workflow even better. So let's try it out. We'll go ahead and move our latents to image node down, and we will add a new node called resize latents. What you'll notice is that it's looking for a very specific width and height. In this case, let's go ahead and go up to 1024 by 1024. And we'll connect our latents up to that node. We'll then add another denoise latents node. I'll go ahead and copy this one over. We'll pass the latents in to this node. We're also going to need our positive and negative conditioning to be passed in again. So we'll connect those over. We'll also need our UNet model connected, so we'll connect that over here. And we'll go ahead and add in, select both our random integer and noise nodes, copy and paste those, bring those up, and then we'll have that random noise passed in here. And for this image to image pass, we're going to want that denoising strength to be relatively low. So we'll start maybe 70% of the way through that denoising process. We'll then take our latents to image node, copy over the latents, and take our VAE, pop that into that node, and we now have our high-res workflow ready to generate an image. For the sake of demonstration here, I'll go ahead and leave this node in and have it save that intermediate image into the gallery so that we can see what it looked like beforehand and after. But let's go ahead and create a new prompt and see what we get. And we'll go ahead and create a pretty simple fantasy prompt and see what we get. Uh-oh, looks like we ran into an error. Wonder what it was that I messed up. Well, luckily there are some useful tips inside of the app. You can actually see that it was something with our denoise latence node. And inside of the console and Invoke, we'll note that it was our noise node that gave us an issue. So let's take a look and see what's wrong with that node. Ah, I see it right there. Our noise node is 512 by 512, but we resized our latence to 1024 by 1024. So it's giving us an error because these aren't the same size. So I'll go ahead and update our noise node to 1024 by 1024. And we'll go ahead and collapse that up. And back down. And we'll go ahead and give that a shot once more. And we can see both of our wizards inside of the UI. This is our 512 by 512 image, and we can see the improved detail on our high-res image. Go ahead and right-click and open that in a new tab to see it in all of its glory and detail. Now, when we're satisfied with a workflow like this, we can simply download that workflow and reuse that later. We can also load the workflow by right-clicking the image that we generated from the workflow editor and using the load workflow button. If we plan on sharing this around with our team or the community, we can add in some additional information that will be passed along with that metadata and give some additional context and details inside of the workflow. It's also useful if you plan on sharing to add notes, which you can do inside of each node. You can add a notes node into your workflow as well and type notes here. You can also include a short description or notes inside of the workflow details itself. Hopefully, now that we've gone through some of the basic fundamentals of the more specific steps in the denoising workflow, you now have a better grasp of the basics and feel confident to start experimenting and exploring with image manipulation inside of the workflow editor itself. There are a ton of custom nodes that the community has created to do everything from bring a large language model in to generate prompts for you, to automatically identifying faces and adding better details without having to lift a finger. These are just a few of the ways that you can extend our workflow system to truly customize it to fit your creative needs. And we're excited to see what you create with it. Stay tuned. We've got more videos coming soon to do more advanced workflows, as well as dig in to some of the new features on the unified campus. If you're interested in developing new capabilities for our workflows by adding custom nodes to the growing community library, or if you want to get directly involved with the creation of our interface, join our Discord and reach out to get started. We'll see you next time. Take care.